Okay, guys, we are going to talk about how to solve equation involve indices, especially negative indices. There are multiple ways to solve it, but I prefer to use this method. I prefer to change them into the same base. Yeah. Have you recognized 4 can turn into base 2? Yeah, you do? Okay, great. So 2 to the power x is equal to 1 over 2 squared. 2 squared is 4. And then we could write, remember the rules? When you switch the position from denominator to numerator, the sign for the index change. So it was a positive here, so it become negative. See, it has from denominator become numerator, but the sign of the index have to change. So whenever you're able to write at the same base 2, then obviously the index has to be equal, and hence we equate the index. Okay, now try again by yourself for B. You can pause the video. Okay, good. Now, for those who recognize the 32, it's 2 to the power 5. Okay, so 2 to the power 5 is, if you rearrange it, you want to switch your position, want to make it denominator, be careful. This is a plus here, it become minus 5. Okay, so logically, if they're same base, then the index has to be equal. That is what we do. Got it? Okay, now let's move on to the second thought, fractions. Similarly, 2 over 3 x, it's equal to, you can change 9 is 3 squared, 4 is 2 squared, you recognize something? Now, the rules say if the index are identical, you are allowed to write them together like this. Now, if the index are not the same, obviously we cannot put them together in the bracket, right? Okay, so this is not, I cannot do anything. All right, so, but if we compare carefully that, hey, this is 2 over 3 and my right hand side is 3 over 2. No, that's not right. Now again, the power of negative index. So when it change the sign of the index become positive to negative or negative to positive, the numerator and denominator swap. See that? Now they have the same base. So obviously the x is negative 2. Okay, you may pause the video and try F and check with it afterwards. All right. So 5 is 5 power 3. 8 is 2 to the power 3. Again, if they're same index, you can put them together and write as one bracket. Now, one more time, the sign, this is a positive. It can change to negative. The condition is, what happened? What has changes to the numbers? The number become reciprocal. Okay, numerator become denominator, denominator become numerator, they swap. Okay, reciprocal. So x equal to minus 3. Got it? Okay. You can pause the video, write your working out. Now let's try the last time. Again, there are 2 ways to solve this question. You could, okay, some say, can I bring this one to here become multiply? Yes, you can. 1 equal to 1 times 2 to the power x is 2 to the power x. But you may be forgotten, like, hey, how can I change 1 to base 2? Do not forget 2 to the power 0. Anything power 0, it's 1. Whenever you see 1, you can change 6 to the power 0, you can change 9 to the power 0, you can change x, 10 to the power 0, anything. But anything power 0, it's 1, index lower. All right, so again, the answer is x equal to 0. Now, say another student say, no, I didn't do it. Can I make my left-hand side 2 to the same base like you did earlier? Yes, we can do that. So get this one, it's become 2. See, it was a positive x, it become negative x over 1, but where we don't write the over 1. Yeah. And same thing equal to 1. Now we're going to change 1 into base 2. So negative x equal to 0, x equal to 0. Okay, so this is the alternative way to solve it. Okay, let's look at another question like J. Hopefully recognize 1 over 25 can change into the base 20, base 5. Okay, 5 squared is 25 and 5 power negative 2, it's 1 over 25. Now, when they have the same base, it's all right for you to equate the index. Yeah, the index should be the same. And then you solve it. Oh, what a coincidence. X is equal to 0. Got it? Okay, so hopefully you know how to solve the simple in these equations.